In this video, we're going to continue our series on Python objects with sets and tuples. Let's jump in. To start, let's look at sets, which are collections of unique hashable objects. And hashable objects, remember, are a little complicated to define, but all numeric objects and all strings are hashable. So think about hashable objects as numbers and strings. The syntax of sets is similar to the syntax of dictionaries because sets are delimited by curly brackets like you see here. Their elements are separated by commas. The difference is that sets don't contain key value pairs separated by colons. In syntactic terms, what I've written right here is a set display. I'm assigning this set to a variable called tech companies and this set to a variable called retail companies. They contain the tickers of Apple, Google, and Amazon for my tech companies, and Walmart, Amazon again, and Target for retail companies. Here I'm printing these sets out and I'm checking their type using the type function. When I do that, I see my set displays again, and the type function tells me that these objects are sets. Set operations include union, intersection, and difference, among others which you can find in the Python documentation. Union combines all of the elements of two sets. Intersection finds the elements that they hold in common, and difference removes common elements from the first set. So order matters with difference. Order does not matter with union and intersection. If I execute this, we can see that the union of tech companies and retail companies gives me 5 elements: Google, Amazon, and Apple, my tech companies, and Walmart, Amazon, and Target as my retail companies. If I ask for the intersection, the common elements of these two sets, Python identifies that Amazon is in both of them. If I ask for the difference, tech companies minus retail companies, I'm using the minus operator, but it performs a different operation when you pass sets as its operands. So tech companies minus retail companies, the common elements are removed from tech companies. We know there's only one, which is Amazon. So we get tech companies minus Amazon, Google, and Apple. If we switch the order of these two sets, retail companies minus tech companies, Amazon's removed from my retail companies, and I'm left with Walmart and Target. Sets can't contain duplicates. If I try to pass duplicates, here I have the ticker for ConocoPhillips listed twice. If I try to pass duplicates to a set, it will be removed, and my set will only contain unique values. For that reason, you can use the set function to remove duplicates from lists. Here I have a list called stock purchase list, and it contains tickers for ExxonMobil, Amazon, Microsoft, Amazon again, and Walmart. If I convert this list into a set by passing it to the set function and then assigning that to the variable stock purchase set, my duplicates are removed from my list. So this can be useful if you want to count the number of unique members in a list. In order to do that, you might want to use the length function, which works on sets just like with lists or dictionaries. If I execute this cell, I see that stock purchase set contains 4 unique values. I can also use the in keyword with sets to check for membership. So here I'm asking, is Apple in energy companies? And the answer is no, it's not. One more container type that you should know about is tuples. Tuples are immutable lists, and immutable means that you can't change their elements. Other than that, they're identical to lists. Syntactically, there's a small difference. They are delimited with parentheses instead of square brackets. If I create a tuple and pass it to my type function, Python tells me it is a tuple type object. Like with lists, tuples can be subscripted, like you see here, and they can be sliced. Unlike with lists, a slicing of a tuple returns a tuple. Once you create a tuple, you can't change its elements. Here, I'm trying to assign a new value to the element associated with index 1 in this tuple, which would be the integer 2. If I execute this cell, Python raises a type error and tells me the tuple object doesn't support item assignment. It's immutable. You can't change its elements. If all of the elements in a tuple are hashable, then a tuple is hashable and can be used as a dictionary key and a member of a set. So here, I'm creating a dictionary called testdict, and I'm using as a key example tuple, which we just created up here. Example tuple only contains the integers 1, 2, and 3, and we know that numbers are hashable objects. So this tuple only contains hashable objects, which means it is hashable, which means it can be used as a dictionary key. If I execute this cell, there's no problem. I have a dictionary. My key is the tuple containing 1, 2, and 3, and my value is this string. I can also use a tuple as an element of another tuple if that tuple is hashable because it contains only hashable objects. If I were to create a tuple inside this set with parentheses that contained maybe an integer or two, but also a list, the interpreter would raise a type error telling me that I'm using an unhashable type in this set. It's okay to create a tuple that contains an unhashable type. Like this list is not hashable. I can pass it as an element to this tuple, and that's okay. The problem is when I try to use an unhashable tuple in a set or as a dictionary key. You can't do that. So sets are just like lists, but they're immutable. Because they're immutable, they can be hashable when they contain only hashable elements. Thanks for watching this video on set and tuple objects in Python. If it was helpful, please give the video a like. And if you want to see more, subscribe to our channel, and I'll see you in the next video.